All right now. So, like I said, we'll be checking organic chemistry today. We'll be checking the core things in organic chemistry. For today's class, these are the things that we are expected to check through. We will check through hydrocarbons, check through alcohols, check through hydrocarbons, under the hydrocarbons, we'll be talking about the aliphatic, the aromatic, we're talking about the alkane, their reactions, their preparation, and their uses. Then we check alcohols, we check their reactions and their preparation too. We check acids, we check polymers, and we check molecules, check carbohydrates, we check protein, check vitamins. So it is a very wide topic, but then it is not as hard as we think it is once we understand how it works. There is no issue at all. All right, so let's start with the first part, the hydrocarbons. So let's go to organic chemistry. Organic chemistry is just a branch of chemistry that entails carbon compounds only. This with carbon compounds, but it excludes simple inorganic carbon compounds like CO2, like carbon. Sorry, please give me a few seconds. I want to. All right, sorry for that. So that is organic chemistry. It's just a bunch of chemistry that deals with carbon compounds, which exclude simple inorganic carbon compounds like CO2 and other carbonates. So the first thing you need to understand about organic chemistry is the homologous series. And the homologous series. So homologous series is a family of organic compounds that has the same general formula. So by the time we begin to see alkane, aquanol, alkana, and all, you see that they have a consistent general formula. So the first thing that when you see a family that has a consistent general formula, that's the homologous series. They have similar chemical properties. Similar chemical properties. They have gradual change in physical properties. So this, they may not ask question on this, and they can ask you, but that is not where we are going to. Gradual change in physical properties, and the successive member, they differ from each other by CH2 group. That is the change that occurs within a group. If you see alkane, alkane is CnH2n. That is their own general formula. And every compound under alkane, they have similar chemical properties. And there is a gradual change in their physical property from gas and their reaction to other similar physical properties. And there is a change of CH2. For example, if you check the first compound, in alkane, which is CnH2n C2H4. The general formula for alkane is CnH2n plus 2. So the first one, which is 18, has C2H6. So CH4 methane is the first compound in organic in alkane family. So the next one, which is 18, if we add CH2 to methane, for example, it will give us C2H6 plus CH2. So these two will give us C2H6, which is 18, right? And if we add CH2 to 18, it will also give us C2H8, which is propane, and so on and so forth. So that is what homologous series is trying to talk about. So let's start with the aliphatic hydrocarbons. The aliphatic hydrocarbons. Who just joined the class now? So all the guys, all the students here today, you're all guys. The ladies are on group. Okay, so aliphatic hydrocarbons, that is where we'll be checking the alkane and all. So the aliphatic hydrocarbons, the hydrocarbon that contain carbon and hydrogen alone. The hydrocarbons that contain only carbon and hydrogen. So I'll be fast very soon. This is just a skimming class. Just want to summarize the class. So let's start with the first, which is alkanes. So the first you need to know about alkane is the general formula, which is CnH2n plus 2. Is that taken? And you all know that they have single covalent bond, isn't it? The single covalent bond exists between the carbon to carbon atoms, and they are the least reactive. In case they have to arrange the reactivity of the hydrocarbons, alkane, and alkyne, the alkane is the least reactive. Is that taken? Now, before we go to their reaction and their preparation, let me quickly give you one or two properties of alkane. The properties of alkane. They are insoluble in water. They burn with flame. And they have low reactivity. Now, let us go to the main thing under alkane, which is the reactions. Please, I want you to pay attention to this place. Everything I've been teaching you so far is just theory. So these are the places they can ask you questions. So alkane has two major reactions. It has the substitution reaction and the combustion reaction. They can test you a lot in this aspect. So they have the substitution reaction and the combustion reaction. So let's start with the substitution reaction and let's see what we mean by substitution reaction. When we say substitute, it simply means we are removing one in order to add one, isn't it? So we are removing a species in order to keep a species. That is what substitution reaction occurs. So the first substitution reaction that I want us to check is halogenation. halogenation using UV light or in sunlight. Anyone? In case they ask you. So this halogenation reaction, from the word halogen, you know that this is talking about all these electrovalent atoms that has -1, that is gaining one electron in order to have octet structures like the chlorine, the fluorine, the bromine, the iodine, the astatine, and all. So in halogenation reaction, what happens is that a hydrogen atom in the alkene will be replaced by the halogen atom that you are adding to the alkene. Like you will substitute a halogen atom with a hydrogen atom. They get that. So this is the general formula in case they ask you. That means if alkene is combining with halogen under UV light, it is the hydrogen here will be replaced by hydrogen to give halogens. I will give you an example now, and it will give you hydrogen halide. Hydrogen uh, let's say, for example, let's pick the reaction of methane with chlorine as an example. Methane reacting with chlorine. So they can ask you to show the substitution reactions or the halogenation of methane with chlorine or any other halogen. So the chemical formula, the molecular formula for uh, methane is CH4, right? That's CH4 plus chlorine. Chlorine is a diatomic gas. That's Cl2, isn't it? They said in the presence of UV. So now we said you will substitute a halogen atom. You substitute it with a hydrogen atom. This simply means you will just remove one hydrogen atom and you will add one chlorine atom in there. So if you remove one hydrogen atom from CH4, it will remain CH3, right? Now, if you add one chlorine atom, that would be CH3Cl, isn't it? And that means it will mean the hydrogen you remove from this place is still there. There's a chlorine that is left here. So that will give us HCl, isn't it? That will be CH3Cl plus HCl. So they said it will give us a haloalkane and it will give us an hydrogen halide. So the hydrogen halide here is the hydrochloric acid. Is that taken? So you can see how methane reacts with chlorine gas, and one hydrogen atom in methane is being replaced by the chlorine. And we have chloromethane, which is CH3Cl, and hydrogen chloride, which is HCl. Please, is that taken? I believe you can do any halogenation reaction. Is that true? No answer. So we have more hydrogen halogenation, more substitution reaction that can occur from this one that we did here. No, we stop with CH3Cl. This CH3Cl, the hydrogen here can still be replaced. No, there's still hydrogen here. So in case they have to give you the full substitution reactions of and alkane. That CH3Cl can still proceed. So we have CH3Cl still with halogen to produce, in depends of UV, to still produce alloalkane. So one chlorine will come here again to replace one hydrogen. So if you move one hydrogen from here, it remains CH2, isn't it? That will be CH2. If we add one chlorine here, it will become Cl2, isn't it? That's Cl2 plus, we said it will always give us hydrogen halide, which is hydrogen chloride. Is that taken? So this is dichloromethane. The first one is chloromethane. This one we have two chlorine. So this is dichloromethane. This dichloromethane also can still undergo substitution reaction again to give CH2Cl2, combining with Cl2 again in the presence of UV light to give C. This chlorine will replace one hydrogen here. That will be CHCl3 plus hydrogen. This is chloroform, total chloromethane. That's chloroform. So polyazine is in the class. And this CHCl3, I will stop the class in the next 10 minutes. So I believe the reason why you guys didn't join the class is because you know it's already. I really don't have the time also. It depends of UV to also undergo substitution reaction to give C. Hydrogen is left to receive as carbon tetrachloride plus HCl. So that is it. You know, there's no hydrogen here again. So this cannot undergo further substitution reaction. I hope that is clear. So let me quickly move to the combustion reaction. Combustion reaction. So when you say combustion, it simply means alkane can burn in oxygen to release heat and energy. So combustion reaction just talk about the burning of alkanes, the burning of alkanes in oxygen, the burning of alkanes in oxygen to release heat and energy. So the products that we always have in combustion reaction of alkane, they are usually carbon dioxide or carbon dioxide, CO2, and water, H2O. And this is the major reason why alkanes are majorly used as fuels. In case they ask you, it is because they can undergo combustion reaction to give out CO2 and water. So let's talk about the combustion reaction of uh, alkane. So under the combustion of reaction of alkane, we have the complete combustion and the incomplete combustion. So complete combustion is when an alkane burns completely in oxygen to form carbon dioxide and water. So let's check some example. So let's check complete combustion of alkane. So I said alkane has two type of reaction. What's the first one? Substitution reaction. The second one is what? Combustion reaction. Alkane does not undergo addition reaction. Is that taken? They don't undergo polymerization reaction. They only undergo substitution reactions and combustion reaction. Now let's talk about combustion of methane. Let's check methane. So the formula for methane is CH4, right? So if it combust in here, that is oxygen, O2. We said it will give us CO2 and water. So don't forget to put it there in case you see an option that does not have it. That is not totally correct. So CH4 plus O2 give us CO2 and water. So the next thing is to say balance. I don't think it's balanced because we have two oxygen here, we have three oxygen here. So how do we balance it? That means we need to make oxygen even by adding, we have four hydrogen here, so we can add two here. So we have four hydrogen, and how many oxygen do we have? We have two, which is four. So we have to put two here also. So this is balance. That is combustion reaction. And this is an example of a complete combustion. So let's do another example. Combustion with ethane, combustion of ethane. Ethane is C2H6, right? So if ethane combusts in air, that will be C2H6 plus O2, right? To give CO2 plus water. Is that taken? So you can balance it. How do we balance this? We have one carbon here. We have two carbon here, six hydrogen. We have two hydrogen. We have how many oxygen? We have seven. So how can we balance? If we had two here, this would be two carbon, four oxygen. Okay. You can add two here, four carbon, 12 hydrogen, 12 hydrogen. How about oxygen? Two. This is 8. Then this is this is 8. This is 6, 14. So we put 7 there. Please, I hope that is clear. So let's quickly move to the second part of the combustion reaction, the incomplete combustion. The incomplete combustion. So this one is talking about limited oxygen supply. Like the oxygen is not much. The oxygen that is reacting at that time is not enough. So instead of we getting carbon dioxide and water, it will be either carbon monoxide and water or carbon and water. Is that taken? So the product from here will either be carbon monoxide or carbon plus water or carbon monoxide plus water. Please, is that taken? Let's say, for example, let's use methane also. So if it is incomplete, that will be CH4 plus O2, isn't it? So it's either we have CO plus H2O or we have CH4 plus O2 and we have carbon plus H2O. Do you get it? Now, if you want to balance this, we have one carbon here. We have one carbon. Okay, carbon is balanced. We have four hydrogen. Yeah. How many hydrogen do we have? We have two. If we had two here, so this would be, we need to make this oxygen here even. So we need to add two here. So if we had two here, we need to add two here too. Because of carbon. Please, are you following me? Hi guys here. Hello. Hi guys here. Okay. So two carbon, we have oxygen. We have two oxygen here. We have one oxygen here. How many? We have 8 hydrogen, so we have to put 4 there. So balance oxygen. So since we have 2, 4, 6, so we have 3 here. So we can balance this also. CH4 plus O2 to give carbon and water. So you have one carbon, 4 hydrogen, so put 2 here. So 2 oxygen. So this is balanced. So I hope you understand the substitution reaction and the combustion reaction of alkane already. In case they ask you for the uses, you can go and read it. You have different uses of the fractional distillation of crude oil. Like the kerosene, for example, we can use it as oil for lantern. In fact, all these jets, they use kerosene as their fuel. I don't know if you've um, picked up a jet before, like you've traveled with a jet within the state or the country before. The uses I traveled with one when I was when I was a teenager around 2008, 2009, thereabouts. So petrol can be used as fuel, bitumen can be used for road constructions, diesel for engines and all. So let's quickly move to alkenes. You guys did not motivate me at all. I took my time to say I want to teach organic chemistry and see the number of turn up. So alkenes, they are unsaturated hydrocarbons. Unsaturated hydrocarbons, and their general formula is CnH2n. The general formula for alkane is CnH2n plus 2. So we said they are unsaturated because they contain double bond. So you'll be seeing C double bond in many alkane. Is that taken? So the first member of the alkene family is the ethene C2H4. So if you put if you make your N the number of atoms of carbon, that's how you'll be getting the sub the other member of the alkene. So we have basic 2 reactions that alkene undergoes. We have the addition reaction and the polymerization reaction. So because of the double bond that alkene has here, they are more reactive than alkane. Because I told you that the least reactive hydrocarbon is the alkane. Hope you still remember. So alkene are more reactive than the alkanes, and if case they ask you, it's because of this double bond that is present in the alkene. So let's quickly check the addition reaction. The addition reactions of alkene. So in this addition reaction, what will happen is the atoms we had across the double bond of the alkene, and they will break the bond to form a single bond. So external atoms will be forming to that alkene family, to that alkene compound. So it will break the bond and it turn the bond, the double bond, into a single bond. Let's say we have a general formula like C double bond C, which is your alkene. Let's say this is the new compound that we are adding, AP. So the next compound that will be formed instead of C double bond C to become C. We get it. Let's start with the first one. Let's talk about the hydrogenation. It's an example of hydrogenation of alkene. It's an example of addition reaction. So from the word hydrogenation, it talks about addition of hydrogen. Is that taken? So hydrogen can be added to an unsaturated hydrocarbon like alkene in the presence of nickel catalyst. For alkene, the substitution reaction occurs in the presence of UV light, the sunlight, isn't it? For this hydrogenation of alkene, the catalyst there is nickel, Ni. So now let's start with the first example, 18 plus hydrogen. How does it react? I'll just give you this example and we'll move on because of our time. 18 plus hydrogen in the presence of nickel to give 18. Now let's look at it. 18 is what? C2H4, isn't it? Plus hydrogen gas, H2, in the presence of nickel. So we said it will change the double bond because if you write this 18 out, 18 is in this form, C double bond C, one hydrogen here, one hydrogen here, one hydrogen, one hydrogen here. So that would be H, 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 H. So it will change this double bond into a single bond to give C2H6. So what it will now become now is this. It will now become C bond C, 3 hydrogen instead of 2 hydrogen. That's C2H6. Do you get it? So that is the addition reaction of the hydrogenation of tin of alkene. So the alkene becomes an alkene. Another one is the halogen addition. Now that we have one person in the class, I think I will end the class in the next 5-10 minutes. You guys will go and read it on your own. The second part under hydrogenation of alkene is the halogen addition. So halogens, we know you have different examples of halogens. So halogens like chlorine, iodine, bromine, they will be hard across the double bond. They'll be added. Let's say, for example, the same 18 C2H4 plus Br2. We said it will change the double bond to a single bond. So that would be C2H4 Br2. Is that taking confidence? Let's say we have C double bond C, one hydrogen, one hydrogen, one hydrogen, one hydrogen, H, 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 H plus Br2 in the presence of nickel as a catalyst. Now, hydrogenation use nickel. You don't need nickel here. You don't need a catalyst here. It will proceed on their own for the halogenation. So this Br2 will break this double bond to give C bond C. So one of these branch here, we have bromine, you have hydrogen, you have hydrogen, you have one of these, we have bromine, you can have hydrogen, you have hydrogen. They get it. So we have 1,2 dibromoethane because we have 2 bromine and they are on the first and the second carbon atom. So that will give us 1,2 di sorry dibromoethane. Is that taken? So another one under the addition reaction of alkene that I want us to check. I will stop on addition of alkene in the class today. Is the addition of hydrogen halide. Addition of hydrogen halides. So let's say, for example, let's still use 18. It's been added to, let's say, hydrogen chloride is an example of hydrogen halide. So it will change the double bond here also to a single bond. So it will become C2. So if hydrogen join this one, hydrogen will become 5. So that will be C2H5 Cl. So let's write it structurally. That's C2H4 hydrogen hydrogen plus HCl to give C. The double bond will be changed to have 3. That would be Cl hydrogen 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 hydrogen. That's chloroethane. Is that taking confidence? For you to are not in the class. The last one that I want us to check under the addition reaction, and that's the last thing we are checking for today. The D is the hydration. That's addition of water. So let's say we had under this one, when you add water to an alkene, it will always produce an alcohol. Is that taken? Let's say we want to add water to 18, for example. It will always produce an alcohol. So for this one, the type of alcohol that we produce depend on the type and the nature of the alkene. If it is 18 that is reacting with water, it will produce an ethanol. If it is a propane that is reacting with water, it will produce a propanol. Is that taken? So this will be C2H. If one hydrogen join this one, it will become H5, right? And remain oxygen and one hydrogen. That's OH. So this reaction, we can use this in the industry. For some of you that will be going to industry, we can use it to produce alcohol. We can use it to produce ethanol. When you add water to respective alkene, it will yield an alcohol. So that's the fourth one under addition reaction of alkene. So the second reaction of alkene is polymerization. Polymerization reaction. So when we talk about polymerization is when small, or let me say many small alkene molecules, they will join together to form a large or a larger molecule. So monomers will join together. They will join together. Maybe this plus this to form a bigger polymer. So that is what polymerization talks about. Let's say we have um, an a small alkene molecules, many small alkene molecules. They will now give rise to a larger molecule that we can now call a polymer. That is what we use in the polymerization of ethane when we want to form polyethylene. So this one will give us C double bond C. So many, this can be 12, this can be 14, depending on the uh, the polymer of the alkene that you want to form. Is that taken? So let's say, for example, now, like I said, the polymerization of ethane. The polymerization of ethane. I will stop in the next 5 minutes. By 1:30, we are done. Let's say N, uh, let's say NC2H4. For example, to give us to many, let's say CH2 bonded with CH2. Put N here. So this is what we use in forming polyethylene or polyethylene and HOP. So that is all about uh, the actions of alkene. So we also have isomerism. You can check it. Isomerism is a phenomenon when two or more compounds they have the same molecular formula, but they have different arrangement of their atoms. So you can go and read it after the class before you go for exam. Go and read isomerism, read it yourself. So under isomerism, we have two. We have the structural isomerism, and we have the geometry isomerism. So under the geometric isomerism, under the structural isomerism, you can go and read on that. You guys didn't join the class. Just go and read under structural isomerism. What we mean by structural isomerism is when compounds have the same molecular formula but different structural arrangement of atoms. That is structural isomerism. Let's say we have normal protein. For example, any protein. You know, normal protein has C4H10 as their molecular formula, isn't it? If you want to write N protein, it will be CH3. Everything inside will be CH2. CH2. Just the first and the last will be CH3, isn't it? This is normal protein. If you count the number of carbon, it will give us 4. And the number of hydrogen will give us 10, isn't it? So this is what we call the straight chain of butane, which is the normal butane. But the second isomer that butane has, we call it isobutane. They still have the same C4H10, but the structural representation is different. In isobutane, we have CH3, and there is one carbon branches that is off the main chain, like it's not just going straight. So we have CH instead of CH2, and one carbon is attached to this place to give us CH3 and CH3. If you still count the number of carbon there, it should still be C4. And if you count the number of hydrogen, it should still be 10. They get it now. So when we talk about isomerism, it's just a phenomenon that makes compounds to have the same molecular formula, but they have different structural formula. So what you need to go and know is go and know the isomers that every compound has. Every compound has. For example, butane, how many isomers does it have? 2. Pentane, how many isomers does it have? 3. Go and know all compounds, their respective isomers in case they ask. I hope that is taken. So we're ending the class now. The other one is the geometric isomer. This guy here. You should go and read it. So this one is common to the unsaturated hydrogen bonds, especially the alkene. It occurs because of the restricted rotation around that double bond in the unsaturated hydrocarbon. So the atoms, they cannot rotate freely. So they will now group themselves in different positions in space. So we have two type of geometric isomerism. We have the cis and the trans. Is that taken under the geometric? So when we talks about the, let me quickly explain the GI, the geometric isomerism. Let's use butane also. That would be but2-ene as an example. So but2-ene will be, since alkene RCNH2N, used to remember. So that would be C4H8, right? Isn't it? So the normal structure for butane, but2-ene is CH3. Since it says 2, so it's between the second carbon put 2 in. Now, we said in geometric isomerism, we have the cis and the trans. Let me quickly explain that. Let's say for the cis, so we have cis put 2 in. Now, when we talk about the cis, it simply means the bulbs that is attached to the arcane is on the same plane, like the same position, the same level, either up or down. They are on the same side of the double bond. For example, if you want to write between, we have double bond between the carbon atoms. So in order to form the C4H8, we had CH3 here. We have CH3 here. And now, so now we have hydrogen and hydrogen here. Don't forget. Carbon must always take 4 bonds. They are tetravalent, isn't it? You can see this CH3. They are the same plane. They are both on the upper side of the bonds, isn't it? So if we count the bond that is attached to carbon, we have 1, 2 here, we have 3 here, we have 4 here. Look at the carbon up here, we have 3 hydrogen attached to it. That's 3 bond already. And the fourth one is attached to the carbon atom, make it in 4. So anytime you are doing an organic chemistry and the number of carbon is not complete, there's a problem. Look at this one here. We have 2 bonds here, 1, 2. We have 3 going down, 1 going up to meet H3. That is 4. So C simply means on the same lane. They are on the same side. And we also have trans. So trans simply means they are on opposite side of the double bond. Just like the example we have above. Let's say we have double bond here. So we can have CH3 here. And this other side, adjacent, we can have CH3. And we have our hydrogen. We have our hydrogen. Yeah. But that is all about the isomerism and all. So the last hydrocarbon, the unsaturated, is the alkyne. They have, you guys will go and read it on yourself. I want to end the class now because you guys didn't actually make it a good class at all. So go and read the alkyne, read their preparation. Alkyne are prepared when water reacts with calcium carbide. Please take note of that. They can ask you. I believe you still remember the general formula of alkyne, which is CnH2n minus 2. They have triple bond. So check the reaction, check the preparation, water with calcium carbide. For example, if you have calcium carbide, it's CaCO2, and it's reacted with water. So it will give us C2H2 time loss. This calcium oxide, hydroxide, CaOH H2. Then you balance so we have 2 hydrogen, 2 hydrogen, that's 4. So we have 2 hydrogen, 2 oxygen, 2 oxygen, 1 calcium, 1 calcium, about carbon, 2 carbon, 2 carbon. So this is complete. So that's one of the ways through which you can prepare an alkyne. In case they ask you, reaction of water with calcium carbide. Please do not forget. And go and read the reaction of alkyne. Under reaction of alkyne, we also have addition reaction that is similar to alkene. I know I told you that alkane does not undergo addition reaction. They only undergo what? Substitution reaction. And what's the one that I give you? Under the reactions of alkene, the combustion reaction, and we talked about the complete and the partial combustion. Yeah, thank you. So for the alkene, they only undergo addition reaction and polymerization reaction. So the alkyne, sorry, they have similar reaction like that of the alkene, in the sense that they undergo addition reaction, they undergo hydrogenation reaction. So once you add hydrogen to um, alkyne, for example, it can give you 18. Once you add hydrogen to 18, it can give you 18. So hydrogenation reaction of alkyne can result to alkene. So intermediary, it can give alkene if you stop. Do you get it? We also have halogen addition, halogenation. You can add halogen to alkyne to give you respective uh, compound. For example, you can add chlorine to alkyne. You can add chlorine to alkyne. You can also add hydrogen halides to alkyne also. Those are the reaction, and also it can undergo combustion reaction, but to undergo complete combustion to give CO2 and water. So from there, you can go and read under aromatic compounds. You read benzene and read the structure, the reaction, the preparation, read the alkanos, the alkanas, that is the aldehyde, their reaction, their preparation. Most importantly, please read classification. Oh, we are done with the class already. Go and read classification of alcohol. Very, very important. The primary alcohol, the secondary alcohol, and the tertiary alcohol. They can ask very sensitive question at that place. No alcohols are classified based on how many carbon atoms that is attached to the carbon that is carrying the OH group. So if one OH is attached to the to one cardinal carbon, that means it is a primary alcohol. Is that taken? So one OH is attached to a carbon that is only bonded to only one other carbon atom. But if the carbon that the hydroxyl, the OH is attached to, is bonded to two other carbon atoms, that is secondary alcohol. And if the OH that is attached to a carbon is bonded to two or three other carbon atoms, that is tertiary alcohol. Hope you still remember that logic. So they can give you different examples. This you can call probably they may not use all this for one or they can give you a, a different example entirely and ask you example they can give you 2-methylpropan 2-hole. And somebody tell me what's 2-methylpropan 2? Is it secondary, primary, or tertiary alcohol? 2-methylpropan 2-hole. Anybody? As we end the class. Nobody. 2-methylpropan 2, is it primary, secondary? It's not secondary. 2-methylpropan 2 is tertiary. Please, you guys go and read it. Go and read it on your own. I would have explained everything to you, but then I don't know why I finished class for about 12 students and only 2 people joined. I don't have time. 2-methylpropan 2. Please go and check different examples. They ask this question enough because they know that many people will say that since this is too hot, too hydroxy, or too hot, it is secondary alcohol. No, like I said, a tertiary alcohol is when the OH is bonded to 3 other carbon atoms. They have this formula, general structure, R3COH. Now let's say, for example, you want to write 2-methyl propyl. So we have CH3 bonded to. So this C on hydrogen is added to it. But this C itself is bonded to three other carbon atom. C is bonded to this guy here, isn't it? C is bonded to this guy here. C is bonded to this guy. These two methyl propane, right? That is the tertiary alcohol. Let's say we have something like this. Please, are you guys following me? Let's say we have something like this: CH3, CH, CH3, and we have OH bonded to this one. So the carbon that OH is bonded to is only bonded to how many carbon atoms? Just two, Abi. 1, 2. This is an example of secondary alcohol. Please, do you get it? So that's how to know the secondary alcohol from the tertiary alcohol. Just look at the carbon that the OH is being attached to. Check it. Is it how many carbon atom is that carbon attached to? Again, if it is one, it's just primary. If it is two, it is second. If it is three, it is tertiary. Is that taken? And go and learn preparation of alcohol. We learn fermentation, reaction. It is the first key preparation of alcohol. How sugar can be converted to alcohol using yeast. So that's the first one. And also in alcohol as a petroleum byproduct also. And what's the reaction of alcohol? We have the combustion reaction, we have the oxidation reaction also. And check lastly the test for alcohol, the Lucas test, and the other guys. It is in your syllabus, they expect you to know it. Just go and check it. And lastly, go and check your biomolecules. Check your biomolecules, your carbohydrates, your proteins, your amino acids, which big helps protein. We have different types of amino acid. We have 20 automated amino acids, cysteine, the lysine, the arginine, and so many more like that. Check it. Time will not permit us to go deep into that because, like I said, you guys did not do the needful. So I wish you guys best of luck in your exam. I wish you success. If you need anything in your chemistry, your biology, you want to reach out to me on the book. Send in your question. I will explain further. And we'll be meeting on Wednesday for your chemistry test. Chemistry mock. The chemistry mock is just a parameter that is trying to prepare you ahead for your JAMB exam. So it will be strictly JAMB style. The question, the minutes, everything, JAMB time. Thank you so much once again. You guys can do it to enjoy your day. Benita, take good care of yourself. Is it fine? The whole topic you have to tell us about this. Can you communicate? I don't understand. The test is on all the topic.